All right, what's going on? This is the second, sorry about that. This is the second set of, this is actually the third video of notes for Unit 7 in Algebra 2. So this is 7.3a, finding all zeros of polynomials. All right, so the last video that we worked on was synthetic division. And the first video was actually solving by factoring. So this video is going to be kind of building on all of those in order to find all the zeros of polynomials, some that don't factor out altogether, all right? Okay, so now I'm not going to get through all of these notes in this one video. There's this section alone is quite a lot. So what I'm going to do, I'm probably going to get through just a couple of these sections, maybe like one like true example, and then we'll go through this here, okay? So what are the zeros of the function? So essentially, zeros of the function, other names for zeros that we can say, you know, x-intercepts, intercepts, solutions or roots, all right? But basically, when you're thinking of zeros of functions, you're thinking of when, or hang on, let me actually erase that. Hold up, I'm trying to think about how to write this, but basically, what numbers I can plug in for x to get 0. That's basically what it means when I ask for the zeros of the function, okay? Now, there's a way that we can kind of use the function itself to kind of narrow it down. This doesn't give us exactly like all of the solutions. It basically gives us a list of what they can be, and that's what's called the rational zero theorem here. So essentially, and what it essentially says is to find the possible rational zeros, and again, this is just possible rational zeros. I'm going to underline that. We're basically going to take the factors of the last number, that p there, and divide it by the factors of the first number, q, using positive and negative, numbers. All right. So okay, so rational zero theorem, factors of the last number divided by the factors of the first number. Let's try it out actually. All right. So if I go for example 1 right here, excuse me, I have p. So my last term is 24. I'm going to list out all the factors. So factors are numbers that multiply to 24. That is 1, and every number that I write, I'm going to write a plus or minus in front. 1, 24. 2 and 12 work. 3 times 8 gets me 24, so I'm going to write 3 and 8. 4 times 6 gets me 24, and 5 doesn't work, and then I'm to 6, so I'm basically done. All right. Then I find the factors of the first term. That's 2. There's only 2 numbers that multiply to 2, and that's 1 and 2. All right. Now, what I'm going to do is I'm going to take all these numbers up here, and I'm going to divide them by all the numbers down here. So I'm going to take this whole list, divide it by 1. Well, that doesn't really change any of my numbers, so that basically means I'm just going to rewrite that list there. I'm going to rewrite the list in this time in order. So I'm going to write the 1, the 2, then the 3, then 4, then kind of that order. So 1 plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and then plus or minus 24. All right. So I divided by 1. All right. I divided all these numbers by 1. This is what I got. Now I divide them all by 2. Well, if I do 1 divided by 2, that's just 1 over 2. 24 divided by 2 is 12. Well, I already have 12, so I don't have to write it again. So I can skip that. 2 divided by 2 is 1. I already have that. I can skip. 12 divided by 2 is 6. I can skip that one. Then I give 3 divided by 2. That is 3 over 2. And then the last ones here, well, they're basically even numbers, so I don't really have to divide them because, well, if I divide 8 by 2, that's 4. I already have that. 4 divided by 2 is 2. I already have that. And then 6 divided by 2 is 3, which I already have. Again, I don't have to rewrite all of the numbers that I divide by 2, just the ones that are not on my list already. So that's my list of possible rational zeros there, all right? To work out this next one here, factors of the last term. Last term is 6. I'm just going to write out factors of 6. I got plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. 1 times 6 is 6, 2 times 3 is 6. I don't think any other numbers work, all right? When I look at that factors of the first one, it's 2 again. I already know what those are. It's going to be plus or minus 1 and plus or minus 2. Now what I'm going to do is I'm going to take all of these numbers and divide them by 1, all right? And again, if I do that, they don't change. They stay as plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6, all right? Now I'm going to go and divide all these by 2. 1 divided by 2, that's plus or minus 1/2. 2 divided by 2, that's 1. I already have that. I can move on. 3 divided by 2, that's 3/2. I don't have that one, so I'm going to add it to my list. And then 6 divided by 2 is 3, so I already have that one, so I'm going to go ahead and add it to the list there, all right? Okay, so again, why do we do this? This is essentially, it narrows our possible solution zeros down to basically these numbers. Now, that doesn't mean a number can't be on this list. One of the zeros can't be on this list, but it would either have to be irrational or imaginary. All right. So if we found a zero on this list that's not on, if we found a zero of, like, say, this function that's not on this list, it would either have to be an irrational number or an imaginary number. But say for like this equation right here, I'm not going to have 5. 5 is not going to be an answer. So is 7. So is 8. Those are not going to be answers. I'm only going to check these numbers right here. All right. So how do we actually use this? So basically what we're going to do is we're going to list the possible zeros. That's basically what we just did. So it's basically P over Q. And then we're going to use synthetic division, hence why I was saying it's important to know what it is to find that one that has no remainder. All right. Now, what I'm going to kind of put in parentheses down here is graphing calculators, and I'll kind of say why in just a second. So let's put graphing calcs down here. All right. And then once you get down there, you basically factor the remaining polynomial and then set each equal to 0 to find the x values, okay? All right, so kind of simple enough with that. Let's actually kind of go through it. So hang on, I'm actually going to do a little bit of editing here. Give me 1 second. All right, sorry about that. So let's go ahead and find all of these zeros here. So we're going to find all the solutions. Now, one thing that I'm going to kind of keep an eye on is this leading degree here, or my highest exponent. So my highest exponent is 3. What that basically tells me is I should have 3 solutions, all right? There are times when you might have less than that, but for the most part, you're gonna have 3 solutions on that one, all right? So let's go through it, all right? So first step is to list all the zeros. So what I'm gonna do is gonna find my P, and divide my P divided by Q. First number is 18. Last number, what I'm looking at is 18, so I want to find all my factors of 18, which is plus or minus 1, plus or minus 18, plus or minus 2, plus or minus 9. 1 times 18 is 18. 2 times 9 is 18. Plus or minus 3, and then plus or minus 6. 3 times 6 is 18. 4, no number multiplies to 4 to get 18. No number multiplies to 5 to get 18. So I'm basically done. Now, my first number is the coefficient out in front of x cubed is 1, which is just plus or minus 1. And again, what I'm going to do is I'm going to take all these numbers here and divide it by all the numbers down here. Well, if I take all these numbers up here divided by 1, I'm just going to be left with plus or minus 1 and literally just this list again. So I'm just going to list it out kind of in order now. So 3 plus or minus 6, plus or minus 9, and then plus or minus 18. I just kind of reordered it here, all right? So these are my possible rational zeros, all right? I can still have an imaginary zero or an irrational zero, but these are the possible rational zeros, all right? Now, what we do next is we plug in this equation up here into synthetic division. So it'd be 1, -4, -15, and then 18. And essentially, what I do from there is I essentially start dividing. I pick one of these zeros, so like +1, -1, 2. I pick a 0 from here, and then I start synthetically dividing. And then I find one that gets me a remainder of 0. But that's really long and tedious, all right? Because that's literally, I'm having to check not only positive 1, 2, 3, 4, 1, 2, 3, 6, 9, and 18, I also have to check the negative of those numbers. So that might take you a long time. What I recommend you use, and I'm going to show you kind of the homework version of this. I also might show you the test version of this. What we can use is what we call Desmos. I'm going to pause the video real quick, and then we'll be right back. Okay, so I have gone from the PowerPoint, which is basically right here, and then I've gone to online, which is essentially desmos.com/calculator. And what I basically did was I essentially just typed in my equation, x cubed minus 4x squared minus 15x plus 18, and I just plugged it in here, all right? And when I plug it in here, I should get a couple x-intercepts, all right? Or I should get maybe 1 or 2 x-intercepts. Now looking at those, I can see that -3, +1, +6. If I look, hey, -3, +1, +6, that is in my list there, all right? So what I can now start to do is, once I see that I have, I'm going to keep that, and then once I see that I have like a rational 0 that's on my list, I'm going to start, synthetically dividing. So I'm going to pick this -3 here, all right? You can start with the 1 or the 6, doesn't matter. I'm just starting with -3. So if we go back here, all right, I'm going to I got x equals -3 as one of my solutions. I'm going to put that out here, all right? And then I'm going to synthetically divide. I take the 1 down, 1 times 3 to get that here. -4 times -3 is -7. Multiply that out. That gets me positive 21. Add those together. That gets me 6. 6 times -3 is -18. And lo and behold, I get a remainder of 0. That's what I want. All right, that's what I want right there. If I don't get that, then then what, you're either doing your math wrong, or it's just not a 0. All right. So I have confirmed that x minus 3 is one of my zeros. Okay, good. Now what I'm going to do is I'm going to take these coefficients here, or these numbers, and I'm going to make a new equation. I'm going to make it right down here. All right. So new, actually, I'm going to kind of make it up there where it's kind of closer. New equation, all right? I synthetically divided x cubed, and I'm going to start with x squared. 1x squared, or just x squared, minus 7x, and then plus the 6. That's my new equation. And then what I'm going to do now is, because I had a bunch of other x-intercepts, so like this 1 right here, I'm going to synthetically divide that new equation by that other 0. So I saw that I had x equals 1 there. I'm going to take this equation and synthetically divide by that. All right, so I'm going to plug this equation in. So 1, -7, and 6. And then I start with that 1 there. And I'm going to synthetically divide. I get 1. 1 times 1 is 1. Minus those out, that's -6. -6 times 1, that's -6. 0. Again, remainder of 0. That's what I want. I have a new equation. I divided x squared, so I'm going to start with an x now. So I have x and then minus 6, all right? So not only did I confirm that x equals 1 is a solution, now I can actually basically kind of use this last one to solve, all right? I got x minus 6, all right? And all I really need to do to solve to get my last one is just set it equal to 0. And if I do that, I should get x equals 6. And if I look at my graphing calculator, hey, look at that. I have a 0 and x-intercept of 6 right there, all right? So I confirm that x equals 6 is, is one of my solutions, all right? So I confirm that. All right, so I know I threw a lot at you in that video. I'm going to go over a couple more examples in the notes in the next couple videos, so just keep an eye on those.